Are you ready to transform your problem-solving speed and dominate coding competitions like Codeforces or LeetCode? Most programmers struggle not because they don't know the code, but because they haven't mastered the underlying patterns of data structures and algorithms. In this video, we will cover DSA competitive programming practice questions and answers. Boost your competitive programming skills with this comprehensive DSA practice session. In this video, we dive deep into 30 high-yield DSA practice questions designed specifically for competitive programming certifications. We'll cover everything from complex graph traversals to optimized dynamic programming states. Before we begin, make sure to grab a pen and paper to trace these algorithms alongside me. What is the time complexity of building a heap from an unsorted array of n elements using the bottom-up heapify method? Option A, O, n log n. Option B, O, n. Option C, O, log n. Option D, O, n squared. The correct answer is B. While it might seem like O, n log n, because each of the n elements could theoretically move log n levels, the actual mathematical summation for the bottom-up approach is a convergent series. Nodes at the bottom, the majority, move very little, while only the root moves the maximum distance. The total complexity is O, n, which is more efficient than inserting elements one by one. In an AVL tree with n nodes, what is the maximum possible height? Option A, log 2, n. Option B, 1.44 log 2, n. Option C, 2 log 2, n. Option D, n, 2. The correct answer is B. AVL trees are strictly balanced. The height of an AVL tree is guaranteed to be logarithmic. Specifically, the maximum height is approximately 1.44 log 2 n plus 2, 1.328. This constant factor, 1.44, is derived from the relation to Fibonacci numbers, as the minimum number of nodes in an AVL tree of height h follows a Fibonacci-like recurrence. Which property is essential for a problem to be solvable using dynamic programming? Option A, greedy choice property. Option B, optimal substructure and overlapping subproblems. Option C, first-in first-out processing. Option D, logarithmic time complexity. The correct answer is B. Dynamic programming, DP, requires two key conditions. 1. Optimal substructure. The optimal solution to the problem contains optimal solutions to subproblems. And 2. Overlapping subproblems. The same subproblems are solved multiple times. Without these, recursion with memoization or iterative DP would not be beneficial. Which algorithm should be used to find the shortest path from a single source in a weighted graph that contains negative edge weights but no negative cycles? Option A, Dijkstra's algorithm. Option B, Prim's algorithm. Option C, Bellman-Ford algorithm. Option D, Kruskal's algorithm. The correct answer is C. Dijkstra's algorithm fails with negative weights because it assumes once a node is visited, its shortest path is found. Bellman-Ford correctly handles negative weights by relaxing all edges up to v1 times. If there are no negative cycles, it provides the correct shortest paths. For negative cycles, it can detect their presence. Which sorting algorithm is considered stable? Option A, quicksort. Option B, heap sort. Option C, merge sort. Option D, selection sort. The correct answer is C. A stable sorting algorithm maintains the relative order of records with equal keys. Merge sort is naturally stable because during the merge process, if two elements are equal, the one from the left subarray is typically chosen first. Quicksort and heap sort are generally unstable due to their partitioning and swapping mechanisms. What does the expression n and n1 equals 0 check for a positive integer n? Option A, if n is even. Option B, if n is odd. Option C, if n is a power of 2. Option D, if n is prime. The correct answer is C. If n is a power of 2, it has only one bit set, e.g., 8 is 1000. Subtracting 1 flips all bits after the set bit, e.g., 7 is 0111. Performing a bitwise in between these two will result in O. For any other number, there will be at least one common bit, making the result non-zero. Which of the following applications primarily uses a stack data structure? Option A, CPU scheduling. Option B, function call stack and recursion. Option C, breadth first search. Option D, print buffer management. The correct answer is B. Stacks follow the last in first out (LIFO) principle. In recursion, the operating system uses a function call stack to keep track of active subroutines, where the last function called must finish first. CPU scheduling and print buffers typically use queues. FIFO and BFS also uses a queue. In a tree, prefix tree, what is the time complexity to search for a string of length k? Option A, O, log n. Option B, O, n. Option C, O, k. Option D, O, n asterisk k. The correct answer is C. In a tree, searching for a word depends only on the number of characters in that word, not the total number of words stored in the tree. For a string of length k, we traverse exactly k nodes, one for each character, making the search complexity O, k. This is highly efficient for dictionary-style lookups. In the fractional knapsack problem, which greedy strategy yields the optimal solution? Option A, pick items with maximum weight first. Option B, pick items with maximum value first. Option C, pick items with maximum value to weight ratio first. Option D, pick items with minimum weight first. The correct answer is C. To maximize the total value in a fractional knapsack, you should prioritize items that give you the most bang for your buck. Sorting by value per unit, weight, VW, and taking as much as possible of the highest ratio items ensures the knapsack is filled with the most efficient value density. A graph with V vertices and E edges is represented by an adjacency list. What is the time complexity of a breadth first search? BFS. Option A, O, V squared. Option B, O, V plus E. Option C, O, V asterisk E. Option D, O, E squared. The correct answer is B. In BFS, every vertex is visited exactly once and placed in the queue. For each vertex, we iterate over its adjacent edges. In an adjacency list, the sum of all adjacency lists is proportional to the number of edges. Therefore, the total time spent is O V for vertices and O E for edges, resulting in O V plus E. What is the space complexity of a recursive implementation of binary search? Option A, O, 1. Option B, O, log n. Option C, O, n. Option D, O, n log n. The correct answer is B. Each recursive call adds a frame to the call stack. Since binary search halves the search space at each step, there are a maximum of log n recursive calls. Therefore, the recursive call stack takes O log n space. An iterative version, however, would only use O 1 space. What is load factor in a hash table? Option A, the time taken to hash a key. Option B, the ratio of number of elements to the number of slots. Option C, the number of collisions per insertion. Option D, the size of the hash function in bytes. The correct answer is B. The load factor, alpha, is defined as n per meter, where n is the number of stored entries and m is the number of slots. Buckets. It indicates how full the hash table is. A high load factor increases the probability of collisions, leading to degraded performance, which usually triggers a rehash or resize operation. What is the most efficient way to detect a cycle in a singly linked list? Option A, use two nested loops to compare every node. Option B, Floyd's tortoise and hare algorithm. Option C, sort the linked list. Option D, reverse the linked list. The correct answer is B. Floyd's cycle finding algorithm uses two pointers. A slow one, tortoise, moving one step at a time, and a fast one, hare, moving two steps. If there is a cycle, the fast pointer will eventually catch up to the slow pointer within the loop. This takes O n time and O 1 space. Which of the following is an example of an in-place sorting algorithm? Option A, merge sort. Option B, quick sort. Option C, radix sort. Option D, counting sort. The correct answer is B. An in-place algorithm uses only a small, constant amount of extra storage space, O log n, for recursion stack in quick sort. Merge sort requires O n extra space for merging subarrays. Counting and radix sort also require significant extra space proportional to the input range or size. According to the master theorem, what is the complexity of T n equals 2T n 2 plus O n? Option A, O n. Option B, O n log n. Option C, O n squared. Option D, O log n. The correct answer is B. This recurrence fits case 2 of the master theorem, where A equals 2, B equals 2, and F n equals n caret 1. Since log underscore B, A equals log underscore 2, 2 equals 1, and the exponent of F n is also 1, the complexity is O n caret log underscore B, A asterisk log n, which simplifies to O n log n. This is the standard recurrence for merge sort. The KMP Knuth-Morris-Pratt algorithm uses which auxiliary structure to achieve linear time string matching? Option A, suffix array. Option B, LPS. Longest proper prefix which is also a suffix. Array. Option C. Segment tree. Option D. Adjacency matrix. The correct answer is B. The KMP algorithm pre-processes the pattern to create an LPS array. This array tells the algorithm how many characters can be skipped after a mismatch by identifying the longest prefix of the pattern that is also a suffix of the currently matched portion. This avoids redundant comparisons, leading to O, N plus M, time. Which traversal of a binary search tree, BST, produces the elements in sorted order? Option A, pre-order. Option B, in order. Option C, post-order. Option D, level order. The correct answer is B. In-order traversal visits nodes in the order left, root, right. In a BST, all elements in the left subtree are smaller than the root, and all in the right are larger. Thus, visiting them in this sequence naturally results in an ascending sorted order. What is the time complexity of the n-queens problem for a board of size n? Option A, O, n squared. Option B, O, n. Option C, O, 2 caret n. Option D, O, n log n. The correct answer is B. The n-queens problem is solved using backtracking. In the worst case, you try placing a queen in each of the n columns for the first row, then n1 for the second, and so on. This results in a search space bounded by O, n, though many branches are pruned early due to constraints. Which algorithm is most suitable for finding the minimum spanning tree, MST, of a dense graph? Option A, Kruskal's algorithm. Option B, Prim's algorithm. Option C, Dijkstra's algorithm. Option D, Floyd-Warshall. The correct answer is B. Prim's algorithm with an adjacency matrix has a complexity of O, V squared, which is better for dense graphs, where E is close to V squared. Kruskal's algorithm is O, E log E, or O, E log V, which is typically better for sparse graphs where E is much smaller than V squared. A circular queue is implemented using an array of size max. If front and rear pointers are used, when is the queue considered full? Option A, rear equals max 1. Option B, rear plus 1. Max equals front. Option C, front equals rear. Option D, front equals 0. The correct answer is B. In a circular queue, the rear pointer wraps around to the beginning. To distinguish between an empty and a full queue, we typically leave one slot empty. The queue is full when the next position after rear, calculated using modulo, is front. What is the time complexity of solving the 0/1 knapsack problem with n items and capacity W? Option A, O, 2 caret n. Option B, O, n asterisk W. Option C, O, n plus W. Option D, O, W squared. The correct answer is B. The DP approach uses a table of size n plus 1, x, W plus 1. Each cell represents the maximum value for I items in capacity, J. Since we fill each cell exactly once using constant time operations, the total complexity is O, n asterisk W. Note: This is considered pseudo-polynomial time because it depends on the value of W. In a max heap of size n, what is the complexity of deleting the maximum element? Option A, O, 1. Option B, O, log n. Option C, oxygen mononitride. Option D, O, n log n. The correct answer is B. Deleting the max element involves removing the root, moving the last element to the root position, and then bubble down, heapify down, to restore the heap property. Since the height of the heap is log n, the max number of swaps is log n, resulting in O log n complexity. What is the advantage of using a dynamic array, like ArrayList in Java or vector in C++, over a static array? Option A, O, 1. Access time. Option B, automatic resizing when full. Option C, better memory cache performance. Option D, lower time complexity for deletions. The correct answer is B. Static arrays have a fixed size defined at compile time. Dynamic arrays automatically allocate more memory, usually doubling the size, when they reach capacity. This provides flexibility while still maintaining O. 1. Average, amortized, time for adding elements to the end. Which of the following is true for a directed acyclic graph, DAG? Option A. It must have at least one cycle. Option B. Topological sorting is always possible. Option C. Every node must have at least one incoming edge. Option D. BFS cannot be performed on it. The correct answer is B. A DAG is a directed graph with no cycles. Because there are no cycles, there is always at least one node with an in degree of 0. A source. This allows for a linear ordering of vertices, known as topological sort, where for every directed edge, U, V, vertex U comes before V. Which problem can be solved optimally using a greedy approach? Option A, 0/1 knapsack. Option B, Huffman coding. Option C, longest common subsequence. Option D, matrix chain multiplication. The correct answer is B. Huffman coding is a greedy algorithm used for lossless data compression. It builds an optimal prefix-free tree by always merging the two lowest frequency nodes. 0/1 knapsack, LCS, and matrix chain multiplication require dynamic programming for optimal solutions. Which sorting algorithm performs best when the input is nearly sorted? Option A, quicksort. Option B, insertion sort. Option C, selection sort. Option D, heap sort. The correct answer is B. Insertion sort has a best-case time complexity of O(n) when the array is already or nearly sorted, as it only needs to perform a few comparisons for each element. Other algorithms like selection sort or heap sort always take O(n squared) or O(n log n), regardless of the initial order. What is the complexity of find and union operations in a DSU? Disjoint set union, with path compression and union by rank? Option A, O, log n. Option B, O, 1, average. Option C, O, alpha, n, amortized. Option D, O, n. The correct answer is C. Alpha. n is the inverse Ackermann function, which grows extremely slowly. For all practical purposes, up to n equals 10 to the power of 600, alpha n is less than 5. Using both path compression and union by rank size makes the operations nearly constant time per call. A Fenwick tree, binary indexed tree, is primarily used for Option A. Finding the shortest path in a graph. Option B. Efficiently updating elements and calculating prefix sums. Option C. Storing strings for prefix matching. Option D. Sorting large datasets. The correct answer is B. A Fenwick tree allows both updating an element and calculating the sum of a range. Prefix sum. In O log n time. It is more memory efficient than a segment tree and is often used in competitive programming for dynamic frequency tables or cumulative frequency queries. How do you clear the kth bit of a number n? Option A, n, 1 less than k. Option B, n and tilde, 1 less than k. Option C, n caret, 1 less than k. Option D, n greater than k. The correct answer is B. To clear a bit, we need an operator that forces that bit to 0 while leaving others unchanged. 1 less than k creates a mask with only the kth bit set. Tilde, 1 less than k inverts it so the kth bit is 0 and all others are 1. Performing an AND with this mask clears only the kth bit. What is the maximum number of nodes in a binary tree of height h? Where a tree with only the root has height 0. Option A, 2 caret h. Option B, 2 caret h plus 1, 1. Option C, 2 caret h1. Option D, h squared. The correct answer is B. A full binary tree has 1 node at level 0, 2 at level 1, 4 at level 2, up to 2 caret h at level h. This is a geometric progression. 1 plus 2 plus 4 plus 2 caret h. The sum is given by 2 caret h plus 1, 1, slash 2 to 1 equals 2 caret h plus 1, 1. That concludes our 30-question intensive on data structures and algorithms for competitive programming. Remember, mastering DSA isn't about memorizing solutions. It's about understanding the trade-offs between different data structures and selecting the right tool for the job. If you found these explanations helpful, hit the like button and subscribe for more deep dives into competitive coding patterns. For the complete DSA competitive programming, practice questions course and full certification prep, check the link in the description below.